Welcome to my channel, Marita James, Girls Boys High School. Today we are looking at Form 3 Chemistry, a topic of sulfur and some of its compounds, revision exercise. We look at the flowcharts. Flowchart question 3. Study the flowchart below and answer the question that follows. We have solid J. You pass through moisture and oxygen, you get a brown solid K. Then to solid J you add solid L with a condition of heat, you get solid M. You react M, you pass it through dilute sulfuric acid, we have a colorless gas N. This colorless gas N you purple through copper to salivate, then you get a black precipitate P. We are supposed to identify J, K, L, M, and N. We write an equation for the reaction that occurs between solid M and dilute sulfuric acid. Write an ionic equation for the reaction between N and the copper 2 salivate solution. Then you state and explain the observations meant when N is passed through iron 3 chloride solution, and then we have dilute sulfuric acid. Follow me as I navigate, unpack, and analyze this flowchart. From solid J to brown solid K, we have moist and oxygen. Moist and oxygen, these are the conditions for rusting. So we have this moist and oxygen, they are the conditions for rusting. These are the conditions for rusting. And the only metal which can rust in the presence of moist and oxygen is iron metal. So this solid J is an iron metal. So we write the equation of the reaction where we identify this solid J as an iron metal because of the moist and this oxygen, which are the conditions for rusting. So we can have an iron metal, which is of course a solid, combining with moist. This is in a water vapor in a gaseous form, and then we have combining with oxygen. So we get a compound on the other side. The compound is iron 2 oxide, hydrated iron 2 oxide, this one here, which is now in this case a solid. This one is now our solid K. So we have a brown solid K is an iron 3 hydrated iron 3 oxide. So this one here it is solid K. So having identifying this one as an iron, you react with you add L and then you heat. When you take this L, we are suspecting that this L, this one here, this is sulfur. So we can have this one as sulfur. So you react this one, you can have an iron metal, this in this case, reacting with this sulfur, and then you heat the product. You heat the reactant, you supply heat to the reaction. So when iron metal is reacted with sulfur in the presence of heat, it can form an iron 2 salivate. In this case, this is an iron 2 salivate. So we have this an iron 2 salivate. An iron 2 salivate. In this case, that is our black. So our solid M, we identify this one as solid M as an iron 2 salivate. So we identify this one as, this is an iron 2 salivate, which is of course a black solid. Now, you take this iron 2 salivate, you add dilute sulfuric acid, you get colorless gas N. So what do we have there? So we can have this has iron 2 salivate, in a solid form. This one now, you are adding the dilute sulfuric acid. You add this one as a dilute sulfuric acid. So what do you have? This one will just combine, so you will be having an iron combining with a salivate. So we have this is iron salivate in this case, which is I think in aqueous solution. Then we have saliva combining with this hydrogen. Then we have this one as hydrogen salivate gas. So this colorless gas N, this one here, colorless gas N. So we have this is N, it is hydrogen salivate. So we have this one as an hydrogen salivate. You a colorless gas N, which is hydrogen salivate, you pump through copper salivate. So you can have this gas, which is hydrogen salivate. So you will be having the hydrogen salivate gas. This one now you are pumping through a copper salivate. So if you pump this one as through copper salivate, what do you have? So you will be having copper 1 salivate. So you have this one as copper 1 salivate, 10 plus. So we have SO4 with this hydrogen. So we can have the sulfuric acid on the other side. So we have now our black, the black precipitate. The black precipitate is copper 2 salivate. So this one here, black precipitate, is copper 1 salivate. This one here, this is black. Now let us go to our question. Identify J, K, L, M, and N. So from our discussion there, you get that J, we identify this one J as an iron metal. So we have this one as iron metal, an iron metal. It is the only metal which can rust in the presence of moisture and oxygen, because these are the conditions for rusting. Then K, we identify K. Our K is, we identify our K. Our K is here. We have a brown solid. When an iron metal in the presence of moisture and oxygen, it will form a brown substance, which is rust. So this one is hydrated. It is hydrated iron 2 oxide. So we have this one as hydrated iron 2 oxide. Then we have L is saliva. Then we have M. This one is iron 2 salivate. Then we have N, which is our colorless gas. That one is a hydrogen salivate gas. So we have this one as an hydrogen salivate gas. So write an ionic equation for the reaction between N and the copper 2 salivate. So an ionic equation, we have copper 2 salivate, an ionic equation between gas N. Gas N is we have this as hydrogen salivate gas. This one is reacting with copper 2 salivate. So we have this one as copper 2 salivate. Now we need an ionic equation from here. First of all, you need to have the ions. The ions in hydrogen salivate. The ions in hydrogen salivate, we have hydrogen ions. So we have this one as hydrogen ions. And then we have the salivate ions. So we have this one as the salivate ions. A salivate ion. From copper salivate, this one we have copper ions. and the salivate ions. And then we are forming on the other side we have the product. When these two combine, they will form the sulfuric acid and the copper salivate. So we have also the copper 1 salivate, and then we have the sulfuric acid on this side. So the ions which are present here, this one we cannot be having the ions because it is in a solid form. So this one remains the way they are. On the other side, we can have the ions also here. So we have the hydrogen ions, and then we have the salivate ions. So we need an ionic equation. When writing an ionic equation, there are those ions which do not take part in the reaction, but they are there for the reaction to take place. They are the spectators ions. So the spectators ions, when writing an ionic equation, you just leave them out. You ignore them when writing an ionic equation. So what are the spectators ions? So if we write this the equation here, then we have the spectators ion. We can have the hydrogen salivate, the hydrogen ions. We have hydrogen ions combining with the salivate ions, plus we have the copper ions. Then we have the salivate ions. This on the reactant side. On the product we don't have the ions here because this one exists in a solid form. Then plus the hydrogen ions plus the salivate ions. So we have the spectators ions here. We can have that. So the spectators ions, we have the spectators ions. Spectators ions, we identify this one. We identify this one also. We identify this one, and we identify this one. Those are the spectators ions. They do not take part in a chemical reaction. So when writing an ionic equation, you just leave them out. So we have the copper ions combining with the salivate ions. So we have copper 2 salivate in a solid form, and this is what we have as a black precipitate. So this is an ionic equation. So this is the ionic equation for the formation of a black precipitate P. So you don't need all of this one here. You only need, when you are doing a practice, you do this one somewhere. The only thing required here is only this part, writing an ionic equation, and then you leave the spectators ions out, those ions which does not take part in a chemical reaction. Follow my channel, kindly subscribe, click the notification bell so that you get notified once I upload a new video.